So I'm going to be starting now. So today we're going to be looking at model 2. Like I said last week, we are going to be starting with the second model because we don't really have time to solve more questions. So today we're going to be dealing with angular motion. With angular motion, we're going to be looking at angular velocity and angular acceleration. We're going to be looking at how do you determine the angular displacement. Displacement is represented by theta. Then the angular velocity is represented by omega. Angular acceleration is represented by alpha. And how do you determine the linear acceleration and distance moved by an object? There is actually a relationship between the angular and the linear quantity. We're going to be looking at that as well, the linear and the angular relationship. And then the last aspect of angular motion, there's nothing much in angular motion, is torque, work done, and power. Torque, work done, and power. Torque, work done, and power. Okay, so we're just going to be starting with what angular motion means, which we all know. So this is a rotary motion. So this happens when an object moves in a circular what? In a circular path about the same axis. There is a diagram, there is a picture that I put here just to show an example of a mechanism that is undergoing an angular motion, which is the gears and mesh. For the mechanical student, I'm sure they will understand more of this. So, like you can see here, we have gears. A practical example is a system of gears, as you can see, that are designed to rotate and transfer power and rotational motion between different components in a mechanical device. So that's just a brief introduction of the just to see, because the main essence of this, mostly we have other transmission units like the belt drive system, the pulley that are used in transmitting power and rotational movement. Okay. Um, let's look at the concept now, starting with radians. So radians is an angle. So it's a unit of an angle that is measured as the angle subtended at the center of a cycle. So there's a relationship between degrees and radians. You can actually convert from radians to degrees or degrees to radians. So you can see from the diagram that is shown here. So we have the relationship between um, the angle subtended by these two radii, OA and OA1, at the center, which is theta. And then we have the S, which is the length of an arc. So which now leave us to this relationship that says that the length of an arc, sometimes they're represented by L, but here is represented by S, is equals to the radius multiplied by theta. And then these are the various ways of converting between radians and degree. And when you have one radian is 57.3 degrees, so it simply means that if you want to convert from degrees to radians, we divide by 57.3. So pi radians is equals to 180 degrees. So it now means that 1 radians is equals to 180 over pi. So that is where they got their 57.3. If we divide 180 divided by pi, you will get 57.3. So 1 radian is equivalent to 57.3 what? Degrees. Okay, so that is how this is gotten. So 2 pi is 360 and pi itself is what? Is 180 degrees. So let's look at an illustration here of an angular displacement. This is an angle formed during circular motion. It's measured in radians. Okay, so with the angular displacement, it is represented by what? By theta. So the angular displacement for one revolution is 2 pi. So one revolution, which is 2 pi radians, is 360. So the angular displacement for one revolution is what? Is 2 pi. So basically, with your angular displacement is going to be 2 pi n, because it's one revolution is going to be 2 pi multiplied by 1, making it to what? 2 pi. So with two revolutions, you multiply by what? By 2, and then With 3 revolutions, we multiply by what? By 3. So that is the formula there. That's the empirical formula. The next one is the angular velocity. The angular velocity is a rate of change of angular displacement. Just like normally you know that velocity is distance over time. So when we talk about rate of change, it has to talk to time. So with the original equation being velocity, uh, which is distance over time, it means that the angular velocity is going to be what? Equals to angular displacement over time. Because displacement is the angular form of distance, angular displacement per unit time. So you can easily say that your angular displacement is equals to your angular velocity multiplied by time. Okay, let me just look at something here. Okay, so we know that um, the angular velocity is angular displacement per unit time, and then we established here that the angular displacement is 2 pi n. So this is going to be 2 pi n over time. So it simply means that for 1 second, if you look at this rotation here, OA, if it completes 1 revolution in 1 second, so it's going to be 2 pi n over 1. So we have it as 2 pi n radians per second. Of course, this is 1 second. Okay, for 2 revolutions now, that is where we have the 2 substituted there. Still in 1 second is just going to be a 4 pi. Okay, so the same thing applies to 3 revolutions as well. Your n will be substituted as 3, and then you multiply it by 2 pi. Because it's 1 second, the time is taken as what? As 1. Okay, so this was what I was explaining initially, that you can actually compare this. This is the linear form, change in distance per unit time. So the distance here is the what? Is the angular displacement, which is theta here. Change in distance, change in angular displacement. Okay, so that's the first aspect of angular motion. I'm sure most of you guys, you already have an idea of this. Um, so we can now look at an application, a practical application here. According to the activity here, there was an instruction that was given here that your pi should be used as 3.142. Sometimes in the exam, this will be told as well. Sometimes they will say use your pi as 3.14, sometimes 3.142. So this will actually be checked while you are doing your substitution, that you wrote it as 3.142 or 3.14. Because in the calculator, if you had used the pi in the calculator, it will use this value as 3.142. Okay, I believe in solving calculations to gain more understanding. Let's look at this question. Now the questions there, we were given a flywheel. You can see there is a flywheel there. They said the flywheel rotates at 12 revolutions per second. That arrow there is revolutions per second. Sometimes students are normally puzzled as in, is it revolution or radians? So this R is revolutions per second. But the radius of the wheel is given. The radius of the wheel is given to be 0.4 meters. But the first question says that you must determine the angular velocity. So we're just going to start with the easiest one. These are very simple question. The angular velocity. So the angular velocity, which is the omega. From a question, the first thing you must write down here is your data. So we're given the value of n with 12. Sometimes I like to prefer to write it like this: 12 rev per what? A second. Say the radius of the flywheel is given to be what? 0.4 meters. So we are to determine The first question there is the angular velocity. I believe you have your textbook. I won't be able to. I'll be using my textbook here. You can just open it on Pelego. I'm not sure which page it is. You know the page. You can just let us know. I'm just going to be using this slide and I'm going to be looking at the textbook for the questions. So the first question says that you must determine the angular what? The angular velocity. So the angular velocity, you use the normal formula, which is 2 pi multiplied by 12. Angular velocity is going to be 24 pi what? Radians per second. Okay, per second. Remember, we were able to derive and see the angular velocity in 1 second there, which is 2 pi divided by time. The time is 1 second. So this is going to be 24 pi per second. Or you can just write it as 24 multiplied by 3.142 before it is, because it's stated here that you must use 3.142 as your pi. So you can now multiply and leave your answer in radians per second. So the second question there is you have to determine the angular displacement during 0.2 seconds. So you have been given a time 0.2 second. The angular displacement is theta, is angular velocity multiplied by time, because the angular velocity is the rate of change of what? Angular displacement. So the angular displacement is going to be the angular velocity multiplied by time. And then we're going to have 24 pi multiplied by the time, which is 0.2. This will give us what? This is going to give us 4.8 what? 4.8 pi. I'm just leaving it in terms of pi here. Then you will be able to convert it yourself because the question says that you must use pi as 3.142. Okay, so that's the solution. We're to determine the angular velocity and the angular displacement of that particular flywheel. Okay, so we are now going to be moving to the next one. The second question. First thing you want to write down is your data. Let's look at that. It's a typical exam question: 5 marks, 6 marks, 3 marks, 2 marks. Okay, there's a lot of marks there. The rotational frequency of an axle accelerates uniformly from 10 revolutions per minute to 600 revolution per what? Per minute. To 10 revolutions per minute to what? 600 revolutions per minute. So normally I represent my capital N with the unit of rev. So this is the initial from 10 rev per minute to n to 600 rev per what? Per minute. For, for what? The time is what? 4 seconds. So it means that it takes the axle to accelerate from 10 rev per minute to 600 rev per minute in 4 seconds. I'm also going to be asking you some questions here just to test some knowledge here and there. The first question says that you must determine the angular acceleration. So the angular acceleration is the rate of change of um, angular velocity. So we're talking about the rate of change. Rate has to do with time. So the change is going to be the final minus the initial over time. Okay, so you can write this as 2 pi, 2 pi n, right? So you can write it as n2 minus n initial divided by what? The time. The time is what? 4 seconds. So this can be written as 2 pi. So the final is 600. You need to convert to what? To rev per second. 60 seconds make 1 minute. So you divide by 60 minus 10 over 60 divided by what? 4. This one can be reduced to 2 pi. So we're going to have 10 there. 10 minus 10 over 60. That should give us 0.1 something. Yeah, 0.167, all divided by what? 4. Can someone give me the value of the angular acceleration there? Thank you very much. 4,446. Say 45. Radians per second square. The second question says that just take a snapshot there. I'm going to be moving to the next slide. I'm going to be reading from here. The average angular velocity. The average angular velocity. Okay, so with the average angular velocity is of course you add the two angular velocity together, then you find the average. You divide it by 12 by what? By 2. Okay. So how do you determine let's determine this. This is going to be 2 pi. The first one there is the initial is 10. So we can just leave it. Let's just use the equation the way it is. So with the average angular velocity, you can write it as equals to the average angular velocity is 2 pi n1 plus 2 pi n2 divided by 2. So you can write this as, I want someone to be able to punch the calculator for me. So it's going to be 2 pi. Initial is 10, then plus 2 pi. This one is 600 divided by what? Divided by 2. Can someone assist us in determining the average angular velocity here? 37. The unit is what? Radian per second. The rev is talking about the rotation. Radian is talking about angle. Remember, angular velocity is a rate of change of angular displacement, and angular displacement is measured in radians. Now, if you compare that to the angular velocity to the linear one, is in meters per second. This one is in radians per second. So the meters is linear, and then the radians is just a way of representing the meters. Yes. That one I don't know. The reason why, well, if you are perfect in it, because sometimes when you change and then you forget to change back again, and then out of panic, and then you are just doing your calculations, then you start getting wrong answers. So I advise you not to change. But if you are perfect in doing that, you can change it and then you can be able to use it. But I want to advise you to do that because you might end up making a mistake by not changing it back in the exam. And then you might just end up writing down a wrong answer. Changing from degrees to radians. How do we determine the angular displacement after 4 seconds? The angular displacement, that's the C part. The angular displacement after 4 seconds. Angular displacement is theta, right? The angular displacement after 4 seconds. Angular displacement after 4 seconds. So you can use the angular velocity multiplied by time. But with the angular velocity here, I'm going to use the average angular velocity. So you can also write this one as W1 plus final divided by 2 multiplied by the time. So the angular displacement during 4 seconds, we can write this one as 2 pi n1 plus 2 pi n2 over 2 multiplied by 4. Because I think we already calculated that here. We just multiply by 4. We got the average. It's 1916.37 multiplied by 4. The angular displacement will give us what? Point what? I hope these things are correct. No, automatically it's going to be in radians. You're talking about this, right? Automatically it's going to be in radians per second. Wait. We did converted here, right? To radians per second divided by 60. Let's see here. I think we need to divide by 60 here. This is 10. Oh, we need to divide by 60. So this one is going to be 10 divided by 60. I see now. And this one is going to be 600 divided by 60. Just the same way we did here. I was looking at these values are too large. Can I have another answer here and let's see if 31.94. Let's confirm if what we did is correct if you have access to the answers. That is B, right? So with this one here, let's just erase this one. We will just use the value of, thank you for that observation. We just use the value of the average velocity here, which is 31.94 multiplied by the C part says that during what? 4 seconds. So you multiply by 4. This will give us what? 127, what? 76. The average velocity. Remember, we've determined the average velocity here. So I just multiply by 4. Because the question said angular displacement after 4 seconds. So now, with the angular displacement now being angular velocity multiplied by time. So which one are you going to use? So you use the average angular velocity. Okay. Let's look at the D part. How do you determine the number of revolution in 4 seconds? The number of revolution in 4 seconds, any idea? Can find the average rotational frequency of the initial and the final, a 10 and a 600. Then you convert it to rev per second. That is for 1 second. And then for 4 seconds, you multiply it by 4. You can find, what I'm saying is that you can actually determine the average rotational frequency, this 10 and 600 rev per minute. Then whatever you get, you convert it to revolutions per second. And then you multiply by 4 to get the number of revolution in 4 seconds. So you can just find the average by adding them, dividing them by 2. The 2 rotational frequency and dividing them by 2. It will give in rev per minute. It will give in rev per minute, right? Then you convert to rev per second. That rev per second that you convert it to, that is in revolutions in 1 second. So for 4 seconds now, you multiply it by 4. Now, there's something I want to show you here. They said determine the number of revolution after 4 seconds. So that is revolution per second, right? They're talking about, we are going to be looking at a value in revolutions per second. And when we are looking at a value in revolutions per second, we are actually referring to the rotational frequency. It's the one that will give you an answer in rev per second. So now I have 2 rotational frequency because it accelerates from 10 rev per minute to 600 rev per minute. So I'm going to find the average rotational frequency. I'm going to add the 2 average. You know how to find average. You add the 2 together, divide by 2, isn't it? That's the average. So it's going to give you what? That's 610 divided by 2, right? Let me do it here. The D parts. Okay, so that is the initial plus the final divided by 2. So that is 10 plus what? 600 divided by 2. So this is going to give us what? 610 over 2. Then it will now give us what? 610 over 2 is what? 305. So this is the average rotational frequency in revolutions per minute. 305 revolutions per minute. Now let's convert this to revolutions per second. So you divide by 60, right? So that's going to be 305 divided by 60 is going to give us what? Yes, 5,083. So this is 5,083, right? Rev per what? Per second. The question says that, let me read from here. You have to determine the number of revolution during 4 seconds. So this, I can interpret this to say that It's going to be 5,083 revolution in what? 1 second. So for 4 seconds now, so you are now going to it's now going to be 5,083 multiplied by what? 4. Because this one is 5,083 rev per second. I converted it to rev per second. That is 1 second. So 4 seconds now, you multiply it by 4. So it's going to give you what? 20,33, right? 20,33 rev. That's going to be your answer. This is going to be the rev in what? In 4 seconds. Check the answer and let's just to confirm. Yeah, you see it now. Question 3. Okay, let me test you here with question 3. Can you guys try question 3?